Hello, my students, and welcome to this recorded session on integration. And before we start, I want to revise the differentiation or the first derivative. You know, the first derivative is the slope of the tangent of the function at any point. So here y equal 3x to the power of 2 plus 5x plus 1. Then we can find the first derivative, dy over dx. It will be equal to multiply 3 by 2, it's 6x, then subtract 1. Then the derivative of 5x is going to be 5, and the derivative of 1 is 0. And also here, y equals 3x squared plus 5x plus 8. So dy over dx will be equal to 6x plus 5, and the derivative of 8 is 0. And for the third one, dy over dx will be equal to 6x plus 5. We observe that the first derivative for the three functions are the same, but the three functions are different. Here, y is 3x squared plus 5x plus 1, and here 3x squared plus 5x plus 8, and here 3x squared plus 5x minus 1. If we have the first derivative and we want to go back and get the original function. So here, if dy over dx equals 6x plus 5, I want to get y. So y here in this case is equal to the antiderivative, or we call it the integration of 6x plus 5. You know, the rule of integration is the opposite of differentiation. In differentiation, we multiply the power by the coefficient, then subtract 1. Here we will do the inverse operation. We will add 1 to the power, then divide by the new power. Add 1 to the power, add 1 to the power. Then the next step, divide by the new power. So add 1, divide by the new power, okay? So here, y is the integration of 6x plus 5 with respect to x. So y, add 1 to the power. The power here is 1. So 6x, add 1 to the power will be 2, and divide by the new power. Plus 5x, here it's 5. So add 1 to the power, or multiply it by x, if we have 5. So the integration of 5 is 5x. Do you know why? Because the differentiation of 5x is 5. So the antiderivative is multiplied by x. So it will be 5x to the power of 1 divided by the new power. Plus, I want to get 1 or 8 or negative 1. This constant, we will write, instead of that, we'll write c. So y is equal to 6x to the power of 2 divided by 2, which is 3x to the power of 2 plus 5x plus c. That is the original function. And we couldn't get the constant here, 1 or 8 or minus 1. And we wrote, instead of that, we wrote c. So if y equals x to the power of 5, what is the first derivative? The first derivative, dy over dx, we write the first derivative as dy over dx, multiply the power by the coefficient 1, here 1, then subtract 1 from the power, it's 5x to the power of 2. What if we have dy over dx, which is 5x to the power of 4? And I want to get the original function. So we write it as dy equals 5x to the power of 4 dx. We did cross multiplying. Then integrate the two functions. So the integration of dy is going to be y. And here we want to find the integration. We will write the integration of 5x to the power of 4 dx. So we can skip this step here and write directly y is the integration of 5x to the power of 4 dx. So y is equal to add 1 to the power, then divide by the new power. So it will be 5x to the power of 5, then divide by 5. Okay, then don't forget to write c. C is the constant. So y will be equal to cancel 5 and 5, y is equal to x to the power of 5 plus c. And if you want to differentiate this function dy over dx, you will get 5x to the power of 4. So the power rule, we will add 1 to the power, then divide by the new power. So the integration of x to the power of 8, it will be what? Add 1 to the power. Add 1 to the power to 8. It will be x to the power of 9, then divide by the new power, which is 9. That is the integration. We can write it as 1/9 x to the power of 9. And don't forget to write c. That is the integration of x to the power of 8. What is the integration of 3? The integration of 3 is going to be 3x. The integration of 3 will be 3x. And the function must be simplified. So if we want to find the integration of x multiplied by 3x minus 8. So first and foremost, multiply this x, expand it, x multiplied by 3x, it will be 3x to the power of 2, then minus x times 8, it will be 8x. How can we integrate it? Add 1 to the power, then divide by the new power. So it will be 3x to the power of 3 divided by 3, minus 8x to the power of 2, add 1 to the power is 1, so add 1 will be 2, then divide by the new power. It will be, cancel 3 and 3, it will be x to the power of 3 minus 8 divided by 2, it's 4x to the power of 2. That's it. And don't forget to write c. Let's go to the next example. The integration of x with respect to x, it will be add 1 to the power, it will be x to the power of 2, then divide by the new power, then don't forget to write plus c, so it will be half x squared plus c. And here the integration of y to the power of 8 with respect to y, it will be y to the power of 9, then divide by the new power, 9, then don't forget to write c, which is 1/9 y to the power of 9 plus c. And here is the integration of -3 with respect to x, it will be -3x plus c multiply, because we are integrating with respect to x. In this one here, add 1 to the power, so it will be 6x to the power of -3 plus 1 is -2, then divide by the new power, it will be -2. So, and don't forget to write c, simplify 6 divided by -2, it's -3x to the power of -2, then plus c. As we know, we need to simplify for integration. So I have here x minus 1 over x multiplied by x plus 1 over x. We can tie it up and multiply them. It will be, it's a difference between two squares, so x squared minus 1 over x squared. Multiplied by x squared plus 1 over x squared dx. As you see here, we have also difference between two squares. So it's the integration of x to the power of 4 minus 1 over x to the power of 4 with respect to x. So it's the integration of x to the power of 4 minus, and here 1 over x to the power of 4, it will be x to the power of -4 with respect to x. Now we can integrate because we have a function simplified in its simplest form. So add 1 to the power, then divide by the new power. So it's x to the power of 5 divided by 5 minus. Here it's x. -4 plus 1, add 1 to the power, it will be -3. -4 plus 1, -3, then divide by the new power. Don't forget to write the constant. So it's 1 over 5 fifth x to the power of 5, and negative multiplied by negative positive 1 over 3 x to the power of -3 plus c. That's it. Before doing the integration here, I want to find the differentiation of this function. So if y equals 1/6 multiplied by 2x plus 1 all raised to the power of 6, so dy over dx, multiply the power by this number here. So 6 multiplied by 1 over 6 multiplied by 2x plus 1, the chain rule, to the power of 5. Then multiply by the differentiation of the brackets. It will be 2. Cancel 6 and 6, so we'll end up with dy over dx is equal to 2 multiplied by 2x plus 1 to the power of 5. Let's analyze it here. Here, if we have the differentiated function, if we have the first derivative, here it's the first derivative. And I want to get the original function. I want to do the antiderivative to get the original function. So as you see here, the original function is 1 over 6 multiplied by 2x plus 1 or raised to the power of 6. But forget it now and just focus on the rule we follow in this case. Here it's the function f of x. So f of x here, the original function is 2x plus 1. And this 2 is the derivative, the first derivative of 2x plus 1. So f prime x is 2. So we have f of x and we have here f prime x. And ignore this power. I don't care about the power here. I'm caring about the function. Here it's the original function 2x plus 1. We deal with it as the original function. And here is the derivative of this function, 2. So in this case, to find y directly, add 1 to the power. So it will be f of x, add 1 to the power 2x plus 1 to the power of 6, then divide by the new power. And here 2, just 2 is the first derivative of this function, and don't care about it. We have here the original function f of x, and 2 is the first derivative of this function, the differentiation of f of x. So what is the rule here in this case? Add 1 to the power. So if we have integration of f prime x, the differentiation of f of x, and here the power is n. So what is the original function here? Y is going to be what? F of x to the power of n plus 1 divided by the new power, then plus c. So here in this example, we have 2x plus 1. Deal with it as the function f, 2x plus 1. And f prime here is 2, as it is written here, it's 2. So here the integration is going to be, or the original function y, is 2x plus 1, add 1 to the power 6, then divide by the new power, and don't forget to write c. So y is equal to 1 over 6, 2x plus 1 to the power of 6, and then plus c. That's it. If we looked at this example, we have 3x plus 1 multiplied by x to the power of 3 plus x plus 8 all raised to the power of 5. And I see it's a hard mission to simplify. But if we focused on this function here, x to the power of 3, it's f of x, x to the power of 3 plus x plus 8, and don't write the power, just write the bracket only. And f prime x, it's 3x to the power of 2 plus 1. So we deal with it as a function f of x and its first derivative, f prime x. So in this case, we will apply the rule directly. Add 1 to the power. It will be x power of 3 plus x plus 8. Add 1 to the power, it will be 6. Then divide by the new power. And then write plus c. So it will be 1 over 6, x power of 3 plus x plus 8, all raised to the power of 6 plus c. That's it. Here in this example, we have the integration. We want to find the integration of x multiplied by the square root of x squared minus 15. So we can tidy it up. It's x multiplied by x power of 2 minus 15, all raised to the power of half. So here we have the function. If we look at the function f of x, so f of x, it's x power of 2 minus 15, and f prime x must be 2x to apply the rule. But we have here x. So we can write it again, x power of 2 minus 15, all to the power of half. Just write 2 here and half in front of the integration. Because half multiplied by 2 is x, half times 2 is 1, so it's x. Here we have a function, it's f of x, and here we have its prime, the first derivative, f prime x. So leave this half as it, and apply the rule. It's x power of 2 minus 15. Add 1 to the power, it's 3 over 2. Then divide by the new power divided by 3 over 2. So it will be half, okay, multiplied by, here we have divided by 3 over 2, can write it as 2 over 3. And here it's x squared minus 15, all to the power of 3 over 2. Cancel 2 and 2, it will be 1/3 x power of 2 minus 15, all to the power of 3 over 2 plus c. That's it. The integration of x minus half over the square root of 2x minus 1. So it will be x minus half multiplied by 2x minus 1, all raised to the power of half, and move it up, it will be negative half with respect to the x. You know, here we can multiply them if they are the same. We can multiply this bracket by 2. 2 multiplied by x minus half. You know, 2 multiplied by x minus half, it will be 2x minus 1. So multiply by 2 here and multiply by half, because half times 2, it's the same. I didn't change anything in the question. So here it will be half. The integration of 2 times x is 2x minus 1. And here it's 2x minus 1 to the power of negative half. Just simplifying the expression. So it's a half. The integration of. When multiplying like bases, we add power. So it's 2x minus 1. The power here is 1. 1 plus negative half, it's a half. Okay. Now to apply the rule. This is the function f of x. And f prime x is 2. F prime x is 2. So we need to put 2 to apply the rule. So it's the integration and half as it. We need to put 2 here, okay, to apply the rule to x minus 1 to the power of half. And because we put 2 here in front of this expression, so we need to multiply by half. Why is that? Because here it's the function f of x, and here it's prime, the first derivative, f prime x. Okay, so we'll move half to the next, to in front of the integration. It will be 1 over 4, the integration of 2 multiplied by 2x minus 1 to the power of half. Then it's 1 over 4 as it. Add 1 to the power, we can apply the rule, because here it's the function f, and here it's f prime. Add 1 to the power, it will be 2x minus 1. Add 1 to the power half, it will be 3 over 2. Then divide by the new power, 3 over 2. Okay. Once again, because we don't have much room here, we write here. So it will be 1 over 4. And here it's 3 over 2. It will be 2 over 3. Because it's divided by 3 over 2. It will be times 2 over 3. And here 2x minus 1 to the power of 3 over 2. 2, 1, and here it's 2, so it will be 1 over 6, and here 2x minus 1 to the power of 3 over 2 plus c. That's it. The integration of 3x squared minus 2x plus 1 to the power of 11. Here's the function f of x, and if f of x is 3x squared minus 2x plus 1. So what is f prime x? F prime x, it will be 6x minus 2. So the first, or the derivative of this function must be 6x minus 2. But here we have 3x minus 1. We need to write it as 6x minus 2. So it's the integration of. We can multiply this by 2. So it's 2 multiplied by 3x minus 1 multiplied by 3x squared minus 2x plus 1 to the power of 11. I multiplied by 2, and to balance it, multiply by half. So it's half the integration of 2 times 3x, 6x minus 2, multiplied by 3x squared minus 2x plus 1 to the power of 11. Now we can apply the rule. Here it's the function, and here it's first derivative. So it's a half as it, add 1 to the power, and write the function as it 3x squared minus 2x plus 1. Add 1 to the power, it will be 12, then divide by the new power, which is 12. So it will be 1 over 24 multiplied by 3x squared minus 2x plus 1 to the power of 12, and don't forget to write c. We can simplify this expression because we have here the same power, 5 and 5. So it's the integration of, multiply this x by the bracket, it will be x multiplied by 1 plus 3 over x, and raise all of them to the power of 5. So it's the integration of x times 1, it's x, plus, and x times 3 over x, it will be 3, all raised to the power of 5. Here's the function, and it's the first derivative is 1, and 1 is written here, 1 multiplied by this bracket. So we can integrate it directly. It will be x plus 3 to the power of 6 divided by 6, then write plus c. That's it. In this example, we couldn't apply the rule because the derivative of x plus 3, if the function is x plus 3, so f prime is 1, but we have here x written in front of this bracket, so it might be a trick one. We can write it as x plus 3 minus 3. Do you know, I didn't change this x because 3 and minus 3 can be cancelled. So x is the same as x plus 3 minus 3, multiplied by x plus 3 to the power of 5. And deal with them as here x plus 3, okay, as a whole chunk, multiplied by x plus 3 to the power of 5. So it's the integration of x plus 3 to the power of 6 minus 3 multiplied by x plus 3 to the power of 5 with respect to x. So we have two functions here to integrate. It's the integration of x plus 3 to the power of 6 minus 3, and then the integration of x plus 3 to the power of 5. So the integration here of x plus 3 to the power of 6, add 1 to the power, it's x plus 3 to the power of 7 divided by the new power. And here it's minus 3, add 1 to the power, x plus 3 to the power of 6, then divide by the new power, which is 6, divided by 3, 1, divided by 3, 2, and don't forget to write c. So it will be x plus 3 to the power of 7 over 7, minus half x plus 3 to the power of 6, then plus c. That's it. Here's the integration of x minus 1 multiplied by x plus 4 to the power of 8. We can just write as x minus 1, we can write it as x plus 4 minus 5. Do you know why? Because x plus 4 minus 5 is x minus 1. It's the same. Multiplied by x plus 4 to the power of 5. Now, we will multiply x plus 4 multiplied by x plus 4 to the power of 5, and then minus 5 multiplied by x plus 4 to the power of 5. So it will be the integration of x plus 4 to the power of 6 minus 5, it's x plus 4 to the power of 5. What is the integration of this one? It will be x plus 4, add 1 to the power, then divide by the new power, minus 5. Here it's x plus 4 to the power of 6, then divide by the new power, which is 6, then write plus c, the constant. Okay, that's it. The integration of x squared multiplied by 2x power of 3 plus 8 or raised to the power of 4 to the, with respect to x. So here it's the function f, and if the function f is equal to 2x power of 3 plus 8, then f prime, it will be 6x power of 2. So here it's the integration of 6x power of 2 multiplied by 2x power of 3 plus 8 to the power of 4. What I did, I multiplied here by 6 to get the derivative of this function. Okay, and multiply by 1 over 6, because 1 over 6 times 6, 1 cancel another out. So here we have the function and its derivative. So apply the rule. It will be 1 over 6, then add 1 to the power to x power of 3 plus 8, add 1 to the power 5, then divide by the new power, which is 5, then plus c. Tied it up, it will be 1 over 30 and 2x power of 3 plus 8 all to the power of 5 plus c. If y equals sin x, so the first derivative dy over dx is equal to cosine x. The derivative of sine is cosine. You can go to the previous session and check it out. You'll find the derivative of sine is cosine. And if y is equal to cosine x, so the derivative of cosine is negative sine. What if I want to integrate the integration of cosine x, the antiderivative of cosine x, if I want to get the original function? So the integration of cosine x will be sine x and plus c. And here the integration of sine x, because the derivative of cosine x is negative sine x, so the integration of sine x will be negative cosine x plus c. Here in this example, it's the integration of cosine for x with respect to x. It's the chain rule, because we have here 4x. So here we assume that cosine for x is f of x. What is the integration of 4x? Okay, so here the function 4x, so f of x is 4x. So f prime x will be 4. So we can write it as the integration of 4 cosine 4x. Here it's the function f, it's 4x, and here it's integration, it's differentiation for the first derivative, and write 1 over 4 in front of the integration. So it will be, apply the rule. The integration of cosine is sine, so it will be sine 4x. And here we have 1 over 4. So it will be 1 over 4 sine 4x plus c. And we can do it quickly and directly. The integration of cosine 4x, it will be sine 4x and divided by the coefficient of x 1 over 4 sine 4x plus c. That's it. I want to get the integration of sine 3x with respect to x. So the integration of sine x is negative cosine x. Okay, the integration of sine x is negative cosine x. The antiderivative of sine x is negative cosine x, but we have here 3x. So write it as negative cosine 3x and divide by the coefficient of x. It will be 1 over 3. And some students ask why we are dividing. Here is the explanation. The integration of sine 3x. The chain rule. Here it's the function f of x. What is the derivative of this function? It's 3. So we are going to write here 3, it's f prime x, and multiply it by 1 over 3 to make balance. So here the function and its prime, so find the derivative of this function. Integration of this function. What is the integration of sine 3x? It will be cosine 3x. We have here 1 over 3. So it's 1 over 3 and multiplied by negative cosine 3x. It will be negative 1 over 3 cosine 3x. That's it. The integration of sine squared x plus cosine squared x with respect to x. So here, sine squared x plus cosine squared x simplified, it will be 1. So the integration of 1 with respect to x will be x plus c. Find the integration of 2 cosine squared x minus 1. So 2 cosine squared x minus 1, it's the integration of cosine 2x with respect to x. The integration of cosine is sine. So it's a sine 2x and divided by the coefficient of x. So it will be half sine 2x plus c. Here in this example, we have integration of 2 sine x cosine x. It's the integration of sine 2x. Sine 2x is the same as 2 sine x cosine x. So now we can find the integration of sine 2x. You know the integration of sine is negative cosine. So it will be negative cosine 2x and divided by the coefficient of sine, it's half. So it's negative half cosine 2x plus c. The integration of sine 3x cosine 3x with respect to x. To simplify it, we can write in front of this 2 sine 3x cosine 3x and multiply it by half to make balance. And you know that 2 sine angle, cosine the same angle, it's sine double of the angle. So it's a sine 6x. So we have here half, and we want to find the integration of sine 6x. The integration of sine 6x is cosine. You know, sine is cosine. The integration of sine is, sorry, negative cosine. And what about this half? Leave it. And here you write negative cosine 6x divided by the coefficient of x. So it will be 1 over 2 multiplied by 1 over 6 multiplied by negative cosine x. So it will be negative 1 over 12 cosine 6x. That's it. We need to simplify the expression or the function before finding the integration. So here we can write it as 1 over 1 plus 10 squared x with respect to x. You know 1 plus 10 squared x, it's 6 squared x. So it's 1 over 6 squared x with respect to x. And 1 over 6 squared x, it's cosine squared x with respect to x. Actually, we couldn't find the integration of cosine to x because it's a cosine x multiplied by cosine x. Okay, so let's go to the rule we have studied in trigonometry, which is cosine 2x. As you know, it's 2 cosine squared x minus 1. We can move this one to the next side. So 1 plus cosine 2x is equal to what? Is equal to 2 cosine squared x. Then divide by 2 all times. So cosine squared x is equal to half plus, here it's half cosine 2x. So we're going to write here, instead of cosine squared x, we're going to write half plus half cosine 2x with respect to x. Now we can integrate. So it will be half x and half cosine 2x. You know, the integration, the antiderivative of cosine is sine. Okay. So write half as it, and write here sine 2x multiplied by the 1 over 2. So here we have half x plus, so half x plus. Let's divide it up. Half times half will be 1 over 4 sine 2x. That's it. I hope you enjoyed the session. See you in the coming episodes. Goodbye.